All right, so for our final example of graphing piecewise functions, we have example 6, negative 2x minus 4 if x is less than negative 2, x squared minus 2 if negative 2 is less than or equal to x is less than 1, and 2 if x is greater than or equal to 1. So I recognize that I have changeovers between functions at negative 2 and again at 1. So on the left end, we have negative 2x minus 4. In the middle, we have x squared minus 2. And on the end, we have 2. So let's start with negative 2x minus 4. Again, I'm always going to start with the boundary point. So I'm going to plug in negative 2 to see where it crosses that boundary. So if I do negative 2, that's negative 2 times negative 2, plugging in negative 2 for x, minus 4, which becomes 4 minus 4, which is just 0. And then notice I am going to have an open circle here because its x is less than negative 2. Open circle at 0. Now my slope is negative 2. So that means I would go down to right 1, or since I need to go to the left, I need to go up to left 1. All right, so in the middle, I have a quadratic. Just as I did in example 5, I'm really just going to plug in points there. All right, so the first point I'm going to plug in is negative 2. So if I plug in negative 2 into x squared minus 2, negative 2 squared is 4, minus 2, 2. So I have a circle at 2. This is going to be a closed circle because of the fact that you have negative 2 is less than or equal to x. Because of that equal to part, that one will be closed. So now my next point here is negative 1. Negative 1 squared is 1. Minus 2 is negative 1. There's my next point. Next one is 0. 0 squared is 0. Minus 2 is negative 2. And then my next one is going to be 1, but that one's going to be an open circle because of this just less than sign. So 1 squared is 1, minus 2 is negative 1. So I have an open circle here. So there's my middle section. Little snippet of the parabola. And then the last function is just 2, where x is greater than or equal to 1. So I'm going to have a closed circle at 2. And I'm going to extend all the way out the end. So there is my graphed piecewise function. Now let's talk domain. The domain, the x values, I notice it goes all the way to the left and all the way to the right. So that tells me it goes all the way to negative infinity, all the way to infinity. Now range, this one's going flat across to the right. So this is never going to increase or decrease. Over here, we're going it's going up to infinity. So I have a minimum here at negative 2. So my range is going to be from negative 2 to infinity. Remember, my range is my y value. So I have that included because that's an actual point. It's not an open circle. It's an actual point at negative 2. Other way we could write this is y is greater than or equal to negative 2. Now I can see this one's not continuous because if I trace, I have to pick up my pencil each time. So that is a no for continuous. And now I'm looking at evaluating. So f of negative 2 that would be falling into the x squared minus 2 category because negative 2 is included in this one and not included in the first one. So I'd have negative 2 squared minus 2. So that would be 4 minus 2, which is 2. If I look here at negative 2, I do have a closed circle at 2. That makes sense. F of 0, that would be in the second one because it's between negative 2 and 1. So I would plug that 0 into x squared minus 2. And I'm going to get negative 2 for that one, which makes sense. If I look at the graph, plug in 0, I get negative 2. And the last one, f of 1, 1 falls into this category here. So f of 1 is just 2. If I look at the graph, here's where 1 is, and the closed circle is on 2. There are all of your examples for graphing piecewise functions. Make sure you go ahead and do some practice within your packet to make sure you really understand this.